Good morning, everyone. Sorry I can't be with you today. I'm away visiting another school in their math, but I want to make sure to review some math with you. So I'm going to go through and I'm going to do some problems. I really want you to pretend I'm here with you, and I really want you to focus, to go through the problems and to use my work. And whenever I ask you to do the work on your own, that you're sure that you do go through it and you try it before you go and see the answer. So one thing that I've noticed is that when we're doing greatest common factors, once we've gotten to the first common factor, we've been stopping. Greatest common factor though means the biggest common factor between the two sets of numbers that we're looking at. So today I'm going to start from the 10, and I'm actually going to go up. Because what we've been doing is we've been going down, and some of us, when we hit repeat, have been stopping. But we need to know all the factors because, again, we're looking for the biggest common factor. So let's look at 27 and 36. 27 is not divisible by 10. Neither is 36. 27 is divisible by 9. 9 times 3 equals 27. Let's see, 9 times 4 also equals 36. This is the greatest number that has a factor. If I had done it the opposite way, I would have gotten to 3 because it's times 9, and I would have gotten to 3 here times 12. And some of us have been stopping there, but the biggest number is going to be our greatest common factor. Be careful not to stop just because there's a repeat and then accidentally lose out on what the greatest common factor is. If I had asked you to simplify or reduce and you had not found 9 as the greatest common factor, you wouldn't have gotten the correct answer. Now let's go to the next page. Notice on the bottom of this page I made a little mistake, and the 20 is actually left over from the other page. So when you turn to the next page, go ahead and put 20 on top. And we're going to look at 20 and 40. There are two ways you can do this right now. You can go through all the way down and you make sure you fill out the entire chart. Or you can start at the bottom. And once you find the greatest factor, you know what your greatest common factor is. Please pause this video, try the work, and then hit play when you're ready for me to go over the answer with you. If you're watching me, then you didn't pause it. Okay, now we're going to go over the answer. I'm going to start at 10. 10 times 2 equals 20. 10 times 4 equals 40. I actually already found my greatest common factor. If I had done it the other way, which I'm going to do now, I would have gotten the same answer. Remember, I'm not just stopping at the repeats. 1 times 20, 1 times 40, 2 times 10, 2 times 20. These are two common factors, but they're not my greatest common factor. 3 doesn't work here and doesn't work here. 4 times 5, 4 times 10. Now I'm going to get to a repeat. This is where some of us are stopping. Some of us have now been saying that because I've gotten to a repeat, 4 or 5 must be my greatest common factor. Remember, just because it repeats does not mean it's the greatest common factor. Here this would be 8. And if I had stopped here, I would have missed the 10 on the bottom, which is the greatest common factor. I know I've been saying that a lot, but it's important to keep going through to make sure that we do not miss out on the greatest number that's common between them. 6 doesn't work here, 7 doesn't work here, 8 doesn't work here, and 9 doesn't work here. 10 times 2 equals 20, 10 times 4 equals 40. 10 is my greatest common factor. Now we're going to do the same thing, but we're going to use it to reduce or to simplify. So I want you to go through and pause this video. I want you to find the greatest common factor for 6 or for 24. You can fill in the entire divisibility chart, or you can start from the bottom. Either way, use your greatest common factor here and divide your fraction by your greatest common factor to find a reduced or simplified fraction. Reducing and simplifying always means to divide. Please pause and try it yourself. Okay, you should have an answer already. And I'm actually going to go ahead and I'm going to tell you your answer. Your answer was 6 for your greatest common factor. We'll go over our reduced fraction in a second. Let's start from the bottom this time because we're looking for that greatest one, and it's been a problem for us when we've been repeating. 10 does not work. Nothing above 6 is actually going to work because 6 can't be divisible by a number that's bigger than it. So I can go ahead and cross out 9, 8, and 7. If I can cross it out on one side, even though 8 times 3 equals 24, it won't be common, so I can cross all of those out. Now let's try 6. 6 times 1 and 6 times 4 both equal the numbers we're looking for. 6 times 1 would have been a repeat. 6 times 4 would have been a repeat. Many of us keep stopping there, but if we had done so, we would have missed our greatest common factor. This exact fraction was on our quiz, and most of us got this wrong because we picked either 1, 2, or 3 as a greatest common factor because once we saw the repeat, we stopped. This is not the greatest number that is a factor of both. 6 is. If I take my greatest common factor, I would put 6 over 6. 6 divided by 6 equals 1. And 24 divided by 6 equals 4. Those numbers were right here. That is my reduced or my simplified fraction. This would be your correct answer. We're going to go ahead and we're going to turn to the next page. On this next page, we have one more, 4/12. Please go ahead and reduce this fraction, simplify this fraction, but first make sure you find the correct greatest common factor. Please pause this video and give it a try. Okay, I hope you paused. I hope you took the time to do this work. For some of you, just pretend I'm there because if you had not paused and you don't do the work, then you're not going to get the practice that you need. But I know that you did the work, so I'm going to go ahead and I'm going to give you the answer. I'm going to start at the top this time, and I'm going to go all the way down just to make sure. 1 times 4 equals 4. 1 times 12 equals 12. 2 times 2 equals 4, and 2 times 6 equals 12. 3 times nothing equals 4. I'm going to cross that out. This is a factor, but if I cross it out on one side, it's clearly not common. So I'll cross it out on the other side. 4 times 1 equals 4. This is a repeat, but do not get tricked. It doesn't mean I stop. 4 times 3 equals 12. All of the numbers that are bigger than 4 will not be divisible by them. So I don't have to do any of these. If I don't do it on one side, I don't have to do it on the other side. This is only true for greatest common factor, but now I already found my greatest common factor. 4/12 divided by my greatest common factor over my greatest common factor, or 4 over 4, another way of saying 1. 4 divided by 4 equals 1. 12 divided by 4 equals 3. I can't be there with you. If you are still confused, make sure you write a little post-it note where you want to get some extra greatest common factor or reducing and simplifying questions so that we can go over it together. We're going to move on to the next section, and then at the end you're going to get a chance to practice this again using these notes. Now we're going to talk about benchmark fractions. Benchmark fractions can mean a lot of things, but today we're going to compare to 1/2. 1/2 is the easiest fraction to use because we know exactly what 1/2 is. It's a lot easier to say I had 1/2 of the Skittles or I had half of a donut today than it is to say to someone that I ate 17/18 of a bagel today. 1/2 is a benchmark because everyone knows what it is. And so when it asks us to compare to a benchmark, we compare to 1/2. Now, we've been doing some very straightforward questions. It's been saying compare blank to 1/2. But sometimes it will give us two fractions and we need to compare them both to 1/2. So look what I have right here. compare 4/7 and 3/9 using a benchmark fraction. That means that I need to compare 4/7 to 1/2, and I need to compare 3/9 to 1/2. Then I can compare them to each other. I need to use least common multiple here. I can't turn 2 into 7, and I can't turn 7 into 2. The least common multiple, let me start with my 7s to see. I know my 2s very well. Oh, right there. 7, 14. I know if I count out my 2s, 10, 12, 14, that's the least common multiple. So now let's multiply these to get to the least common multiple. I'm going to go over here. It's where I have a bit more space. 4/7 times a mystery number equals, to turn it into 14ths, I need to do 2/2. 4 times 8/14, and 1/2 is going to be 7/14. 4/7, therefore, is greater than 1/2. Now let's turn 3/9. Again, if I list out my multiples of 9, I have 9, 18, and I know my 2s will hit 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. So 18 will be my least common multiple. Let's turn 3/9 times a mystery number into 18ths. Again, that will be 2/2. 3 times 2 equals 6. 6/18 is going to be less than 9/18, which is 1/2. So 1/2 is greater than 3/9. If 4/7 is greater than 1/2, and 1/2 is greater than 3/9, then 4/7 must be greater than 3/9. There's a lot of pieces to that, but go ahead and try this. Again, here are the steps. Turn your benchmark fractions both into comparisons with 1/2. So I'll set this up for you. 5/6 question mark 1/2. This one's good because you can turn 1/2 right into sixths. And 3/4 question mark 1/2. Once you've compared them both to 1/2, go ahead and compare them to each other. Please pause this video and convert halves into sixths, halves into fourths, and then write a comparison. So, if you turned halves into sixths, you should have 1/2 times 3/3 equals 3/6. That means that 5/6 is greater. If you convert this, you'll have 1/2 times 2/2, 2/4. That means that 3/4 is greater. In this case, we would have to do a little bit more work. Both fractions are greater than 1/2. So we can't necessarily match them up. The real way we would next do this is actually to turn both of these into 24ths, because that would be the least common multiple. But we won't go into that today. What you can know based on this calculation is that both of these fractions are greater than 1/2. For now, that will be important, and that will be enough. Let's try another one on the bottom. We have 11/24 and 7/16. I'll set this part up for you again. Question mark 1/2 and 7/16 question mark 1/2. Go ahead and see what you find. Please pause and do the work before starting again. Okay, so 1/2, this one was tricky, times 12/12 equals 24ths, which is 12/24. So 1/2 is actually greater here. 1/2, we're turning it into 16ths, is times 8/8. We have 8/16. 1/2 is greater in this case again too. So both of these fractions are less than 1/2. We cannot compare them to each other. We would have to find the greatest common multiple. I'm going to say that again and forget that I said that. We're going to find the least common multiple. So we'd have to turn 24th and 16th in the same denominator, which we will not do today. For now, it's important that you found that 1/2 is greater than 7/16 and 1/2 is greater than 11/24. Now we're going to go to section 3. If you are confused by benchmark fractions, please write a post-it note and have it ready to give to Mr. Acosta so I can work on this with you when I return. Phew, you've made it through a lot. Now we're going to do one more thing that all of you are very good at, yet is designed to trick us. When we have a fraction and we're looking for equivalent fractions can mean that we need to multiply our fraction or we need to divide our fraction. It'll depend on the numbers that we see or the model that we see. First thing I'm going to do in this question, and first thing you should do with all of these questions, is to just tell yourself. It's a very simple thing to observe. I'm starting with a fraction and I'm looking at models. I know that seems simple, but it's important to remember that because we have numbers here, and so the fact that all these cubes are here might trick us. So what should I do? I should turn all of my models into a fraction. I'm going to go ahead and count. I have 6, 12, 18. So this is 12/18. 1, 2, 3, 4, 5. So this is 1, 2, 3, 4. 12/15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15/18. And this one is 6/9. So take a look at 5/6. 5/6, the denominator is 6. This is a denominator of 18, 15, 18, and 9. To turn 6 into any of those numbers means that I must be multiplying. 6 divided by any number cannot be 18 or 15, so I need to multiply. I don't know what I'm multiplying by yet, but I'll figure that out using my model. In the first one I have 18ths. 5/6 times something equals 18ths. Maybe it's 12/18, maybe it's 15/18. I don't know yet until I've done the math. So, using my multiples chart or my fluency with multiplication, I know that 6 times something is 18. 6 times 3 is 18. I need to make sure that this is 3/3, so that it is equivalent to 1. 5 times 3, 5, 10, 15, is 15. That means that my correct answer is C, 15/18. To be honest, many of you had the correct math and miscounted your models. Count them again, count them 3 times. Make sure that these models are correct because all of this will get messed up, even if it's beautiful math, if you did not count correctly. Let's go to the next one. The next one says an equivalent fraction for the area shown in the figure above is blank. Let's start by counting our fraction. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My total pieces is always my denominator. 4/12. Now let's look. I have thirds, twelfths, eighths, and ninths. It might be hard for you to see in my video, so make sure you're following along on your paper. I'll say that again. I have thirds, twelfths, eighths, and ninths. All of these denominators are either the same size or smaller. Smaller means I must be reducing, I must be simplifying, I must be dividing. Now, really quickly, I'm going to go ahead and cross out B and C. 3/12 is not equal to 4/12. We know that. That's just silly. 5/12 is not equal to 4/12. We know that. That's just ridiculous. So, now I'm left with thirds, eighths, and ninths. Let me go ahead and start with number 1, and I'll go down as we go. 4/12 divided by a mystery number equals thirds. I don't know what my mystery number is yet. I don't know what my numerator is yet. I need to find my denominator. 12 divided by what equals 3? Well, I could use my multiples chart, or I could just remember my facts. 3 times 4 equals 12. That means this must be 4 over 4. 4 divided by 4 equals 1. I got lucky there. This is my correct answer right off the bat. If I had gone to choice D and to choice E, I would have seen that 12 divided by nothing equals 8, and 12 divided by nothing equals 9. So those ones wouldn't have been correct either. Okay, we've gone through a lot, and now you have 2 more problems until you're done. You can be very proud of yourself for all the work you've done. Now I want you to go ahead, and I want you to try this on your own. It says, what fraction is equivalent to the model below? I have a model here, and I have models here, but I still need to work with fractions. So I'll count all of them, and I'll count all of them, and I'll see, can I turn this model into any of these models by either multiplying or dividing? Please pause this video and try it by yourself. Then we'll go over the answer. So what did you get? Well, here's how I would do this. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I lost count. It happens to a lot of us. Let's label these so that that doesn't happen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2/16. Okay, now let me look at all my choices. I know I want to dig into the math. I might want to multiply by 2 over 2 or divide by 2 over 2, but do not do any math until you have all of your fractions laid out. It will really guide your thinking. 1, that's my numerator. 1, 2, 3, 4, 5, 6, 7, 8, 1/8. This looks similar. This must be eighths too. So this is 2/8. 1, my numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh my goodness, this one tricks us all the time. We think because it's 16ths up here and 16ths down here that this must be the right answer. No, it cannot be the right answer. 2/16 is only equivalent to 2/16. It cannot be equivalent to 1/16 or 3/16 or 4/16 or 6/16 or 16/16. It must be the same. So this can't be right off the bat. The only 16th that will be equivalent is 2/16. Let's count this one. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No! If it's 16ths, it can't be the same. So now we have eighths. We know we're turning 16ths into eighths. I have a big number, 16, and I'm making it a smaller number, 8. That means I must be dividing. 2/16 divided by a mystery giant 1 equals something eighths. 16 divided by what equals 8? Well, I could use my multiples chart, or I could remember 8 times 2 equals 16. 16 divided by 2 equals 8. This is 2 over 2. Some of us love to now forget that we're dividing and we say, well, 2 divided by 2 equals 4, but that's multiplication. Be careful. 2 divided by 2 equals 1. 1/8. Where do I see 1/8? Choice A. If you did not have choice A, doesn't matter. As long as you followed along on my work and you take the time to go over my work again right now. Okay, we have one problem left to do. I'm not even going to help set you up for this one. I want you to go through and turn your models into fractions and then do all of the work. Please pause the video, then we'll go over the answer together. So what'd you get? My correct answer was C. Mr. Acosta was not kidding. And I know this won't happen on the MCAS, and I know this won't happen on the unit test. But it's true when I tell him that I go through the answers, and if you don't show your work, I change it to the wrong answer. Because then I just think you guessed. This, although right, is very, very wrong. So let's go through the work. I'm going to count my fractions. I already have my fraction here, and I have my models here. 1, 2, 3,